Hello everybody and welcome back to another video. Today we're going to be taking a look at roots and how you can simplify expressions involving roots and exponents. Firstly, make sure you've watched my video about exponents before this because a lot of the topic I'll be covering in this video is also related to exponents. Now let's firstly talk about roots and what they are. Roots are the opposite of exponents and they're written with this sign you can see over here, similar to the division sign but not quite. The number of times you need to divide is on the top left and known as the index, and the number of times you need to divide by is on the right and known as a radicand. Here we can see an example of a root, of an expression with a root. So here we have 64, which is the radicand, and then we have this radical symbol separating the index and the radicand here. This would be read as the cube root of 64, or the third root of 64. And this means that we need to find, in order to solve this, you have to find a number that you can multiply by itself 3 times and which will result in 64. In this case, that number would be 4 because 4 times 4 times 4, or 4 multiplied by itself 3 times is equal to 64. Now here on the right we can see another example, but you can notice that this one has no index. Whenever a root has no index, you can basically think that index means 2, and it isn't written because square roots are commonly found. Here, this would be read as a square root of 64, which would be 8, because 8 times 8 is 64, or 8 times itself multiplied by itself twice is equal to 64. Now that we know what roots are, let's take a look at properties of roots and exponents. The first property you need to know is what happens if the exponent and the index are the same. If the exponent and the index are the same, they can be cancelled out. This is a pretty simple one that you just need to remember, and here are a few examples. Here we have a number to the 4th power to the 4th root, and because roots and exponents are the exact opposite, they'll also cancel out. So this will simply just result in the answer being n. So here in our second example, we have 2 to the 4th power to the 4th root, and again this would just simplify to 2 as the exponent and the root cancel out. Now let's look at the second property which involves simplifying imperfect roots. If the expression cannot be simplified to a whole number, it can still be expressed as a number times a root. Here we have a few examples. So firstly, we have the square root of 8. Notice that the answer cannot be 2 because 2 times 2 is 4. And it cannot be 3 either because 3 times 3 is 9. So it must be somewhere between 2 and 3, which is not a whole number. In order to solve things like this, we can use the property of that roots have. Firstly, let's rewrite 8 as 4 times 2. Now that we have this, we can say that this is equal to the square root of 4 times 2, which is equal to the square root of 4 times the square root of 2, which is just a property that roots have. They can be split up if there's 2 values separated by multiplication. So now we have the square root of 4 times the square root of 2, and you'll notice that the square root of 4 is simply equal to 2. So the answer to this would be 2 times the square root of 2, and this would be the most simplified form. Here we have our second example where we have the cube root of 81. The cube root of 81 we can rewrite as the cube root of 27 times 3, which is equal to the cube root of 27 times the cube root of 3. Now the cube root of 27 is simply 3 because 3 times 3 times 3 is equal to 27. So the most simplified way to write the cube root of 81 is 3 times the cube root of 3. Now the third property is when you're simplifying roots without variables. You can use the preceding 2 properties that we just talked about to simplify roots without exponents and simplify roots that involve variables. So here, our first example, we have the square root of n cubed. We can rewrite n cubed as n squared times n because that would still result in n cubed, and which can be rewritten as the square root of n squared times the square root of n. Now we know from the first property, the same exponent and index, that the square root of n squared is simply equal to n. So this can be rewritten as n times root n. In our second example, we have the cube root of n to the 7th power. Here we can rewrite n to the 7th as n cubed times n cubed times n. And then we can split it up using the second property as the cube root of n cubed times the cube root of n cubed times the cube root of n. Now here this would result in n. The cube root of n cubed again is equal to n, and this can remain as the cube root of n. So we have n times the cube root of n, and because n times n is n squared, this is equal to n squared times the cube root of n. It can be a little confusing when you first look at it, but when you start solving problems using these properties, you can easily do them. The fourth and final property we're going to be looking at is simplifying decimal exponents. In order to solve fractional slash decimal exponents, you have to make the numerator the exponent and the denominator the root. Let's take a look at what I mean by that. Here we have 2 to the power of 0.25. 0.25 can be simplified to, not simplified, but rewritten as 1 over 4. So here we get 2 to the power of 1 over 4. Now the numerator would become the exponent, and the 4 would become the index in our root. And here 2 to the 1 is simply going to be 2, so we don't need to write that in. But here we can use this 4 as the root, so this would become the 4th root of 2. Our second example here is 3 to the power of 0.75, which is rewritten as 3 to the power of 3 over 4, and we use this 3 as the exponent, and we use this 4 as the index. So this becomes 3 cubed to the 4th root, or the 4th root of 3 cubed, and because 3 cubed is 27, the answer would be the 4th root of 27. Thank you for watching, and see you guys in the next one.